So our next speaker is David Wright. He is a physics professor from Tidewater Community College in Virginia, where he has been teaching since 1974. David has an incredible passion for physics, but also he has a super unique ability to connect and inspire his students. They recently shared some of his classroom lessons on Twitter and managed to get over 28 million views. So something good is going on here. I do want to tell you that after we hear David's recorded remarks, he is here live with us for a Q&A. So as you watch, please be thinking of the questions that you may want to pose, and I'll invite you to do so through the Q&A feature on your screen in a few moments. So let's take a look at the following video. I'm sure, without a doubt, David is going to energize you.
Like being a human hockey puck.
On his homemade hoverboard,
Here we go, give me a push.
college physics professor David Wright teaches us Newton's first law. Motion stays in motion.
You have to be enthusiastic in the class because physics has got a reputation as being dull and boring.
No chance of dozing off in Wright's classroom. He's been sharing the gravity of a science he loves at Virginia's Tidewater Community College since 1974. At almost 70, a magnetic machine of energy. Slingshotting himself into demonstrations with fire, pogo sticks, even a bed of nails.
I feel kind of guilty sometimes. They're paying me to have fun.
One student posted this stunt montage just yesterday on Twitter, already watched more than 13 million times.
You have to be going into that classroom every day thinking, what is this guy going to do today?
Literally, yes. Literally.
His class is a roller coaster ride. And while Wright gets thrills from the physics of skydiving and bungee jumping, nothing compares to teaching.
Look what happened.
Using a closet collection of gadgets to engage and inspire.
Nice job. You're a natural. Yeah. I love coming to work in the mornings. I've loved every minute of it.
A passion and a purpose even science can't explain. Katie Beck, NBC News, Virginia Beach, Virginia.
Hello, everyone. My name is David Wright, and I love physics. I also love to teach. I want to commend each of you for being here at the Pathfinders Summer Institute. You're terrific, hardworking teachers striving to become better. Now, in my 45 years of teaching at Tidewater Community College, I've been involved in a lot of professional conferences, attended workshops, read journal articles, talked to colleagues, experimented in the classroom, and trying a way to make my instruction and my teaching better. I love professional development. Let's start by talking about the principle of inertia. Inertia says that objects at rest stay at rest, and objects in motion stay in motion in a straight line at a constant speed unless acted upon by an outside force. Let's see how this works. We've got some dishes. They're at rest. They want to stay at rest. If I pull hard and fast, they'll do that. 1, 2, 3. Awesome. Now, over here in the back of my room here, you'll see an egg, a raw egg on top of a PVC pipe, a pizza pan, and then a container of water underneath. I'm going to use this broom as a striker. It's going to apply force to the pizza pan, knocking the pizza pan that way, but nothing attacks the egg. It should fall straight down because of the principle of inertia. Here we go. 1, 2, 3. Try it again. 1, 2, 3. Ah, perfect. Okay. Now the next principle of inertia has to do with this wheel. It's a bicycle wheel. I'm going to start it spinning. I apply a force to get it going. What keeps it going? I ask my students that question all the time. They say inertia, but no, nothing keeps it going. Inertia is the name of the principle. Inertia is not a force. It'll spin forever until the friction eventually slows it down. But why does it keep going? The answer is, we have no idea. Just the nature of things. That's the answer to a lot of questions in physics. Why do protons attract electrons? And the answer is, because they do. It's their nature. Now, people say that education has a lot of inertia. That means it's hard to get things moving, either to get them started or to change their direction. You may have colleagues that have been teaching the same way for many, many years and have no desire to make any changes in what they're doing. You're at the Pathfinders Institute. You're going to break that status quo. You have great instruction. You're going to collaborate with peers. You're going to have an educational, interactive, and fun experience. And you're going to want to share the experiences with your classes when you get home. You can't wait to do that. Now, you're starting off on a new track, but how do you do it with little funding? Well, one idea is that manual I gave to you beforehand, the video and demo manual. A lot of exercises and things to do that are easy and cheap. I'll give you an example. Even if you're not a physics person, there'd be a lot of exercise you can use in your classes too. This is a Couchball, my favorite physics demonstration device. It's very versatile. It's like the Swiss Army knife of physics demonstration devices. It's so useful. It's easy to see, colorful, easy to catch, and it doesn't bounce. Now, if I toss it back and forth like this, it follows a nice parabolic path, which is what free fall is all about. If I hold it by a couple of strands and I spin it very fast, it flattens out. That's pretty cool. And then it also oscillates back and forth. It's a torsional pendulum. Ooh. Now, if I take the Couchball and I go this way and toss the Couchball that way, watch what happens. The Couchball just dropped down. That's an example of relative velocity. That's so cool. Now, we can also do this. Put the Couchball on a board, hanging from a board like this, spin it in a circle, and the Couchball stays on the board. Yeah, how about that? Fell off at the very end. Try it, you'll love it. Now, demonstrations are a great way to get a discussion going in the class and relate to the real world. I love to ask questions, but so often in class, I'll get 2 or 3 students that raise their hand and the rest of them just are happy just to sit there and do nothing. I want to have an engaging and interactive classroom, so I use a classroom response system, sometimes called clickers. There's also free apps you have on your phone, like Poll Everywhere. One of my favorites is the low-tech version. See, B, A, C, D. That's pretty cool. Because if you use these response systems, you can get the whole class involved in making predictions and answering questions. You can see as an instructor what they're learning, whether they get it or not. It makes them think about things as opposed to just writing it down in their notes, being a scribe. And they don't have to be embarrassed because only you see the answers, not their peers. They don't have to be embarrassed about that. Now, I like to make predictions in class. And then we'll do the experiment, and then we'll talk afterwards about what it all means. So we're going to try it right now with buoyancy. What we've got here is a tank of water and 11 different items we're going to toss into the tank of water, and we'll see whether they sink or whether they float. Now, if we had your clickers or your personal response system, we could have you vote along the way, but you have to keep track yourself. All right, let's start off with a rubber ducky. Start off easy. Rubber ducky. Float or sink? Well, that's an obvious one. You knew it was going to float. It doesn't float very well. This next one's easy. This is a rock, a piece of granite. And it sinks like a rock? Okay, you got that one. The next one's a little tricky. The next one is a golf ball. Okay, vote, golf ball. It sinks, not very quickly, a little more dense than water. A rubber stopper. All right, standard old rubber stopper. Let's see what happens. Boom, down to the bottom it goes. How about a tangerine? Well, floats pretty well. Now, softball. Softball. Look at that. Only floats about halfway down. Has about half the density of water. Let's try an apple. Have you bobbed for apples before? Yeah, that apple does a nice job, doesn't it? Floating. Hard to get with your teeth. Let's try a potato. Just a standard old potato. Sink or float? It sinks. Interesting. How about some grapes? Green grapes and black grapes here. Yeah, they sink to the bottom. Diet root beer. No bubbles down there. Nope, it's floating quite nicely. Floating quite nicely. How about a regular sugar soda? Oh yeah, sinks to the bottom. This brings up a great discussion about buoyancy. It's all about density. For example, an 11-pound bowling ball floats, interestingly enough. Surprise, surprise. A 13-pound bowling ball sinks. Now the students might say, well, it's heavy, that's why it sinks. But 100,000-ton aircraft carrier floats. It's all about density. Bowling balls have exactly the same size. Therefore, the heavier one is also denser, and that's why it sinks. Now, I love to have fun teaching. So I did a long time ago, if I wasn't having fun teaching, my students wouldn't have any fun learning. I also like to make it real world. It makes it relate to what they're doing. I like to use a lot of energy. I figure if I have a lot of energy, a lot of passion on what I'm doing, I can transfer some of that, at least anyway, to the students. Let's see an example of that. Here I've got a basketball. Camera down a little bit. I've got a basketball here. I'm going to bounce it on this tape, on this chair. Menu straight. There we go. And I'm going to bounce the tennis ball. All right. I'm going to bounce them both together. Whoa! The tennis ball went up and hit the ceiling. Where in the world did you get the energy to do that? What's going on? Is it magic? No, it's physics! Because the basketball gave some of its energy to the tennis ball. Like you as an instructor can give some of your energy to your students. It's exciting stuff. Okay, next we got the spinning stool. Sitting on the stool, spins around. Okay, that's like the figure skater. Things are on them, they spin faster. It's good to get the students involved in demonstrations, have them experience the science and not just talk about it. They love it. Here we go. Bricks out, spin around, bring them in, ooh, faster, slow, ooh, faster. And then I'm getting this. I love the students to do these kinds of things. Oh my goodness. All right. I like to be able to explain things that happen in the real world. This is the board. You notice how the grain is on the wood. This is the 1x12 cut into 3-inch pieces. We're going to use this to, oops, too much. Experimentation here. We're going to break this right here on the table. Normally have the students hold it like this. I don't have that right now. So let's see. Right here. Think I can do it? Students aren't sure. Use the heel of my hand here. 1, 2, 3. Hi-ya! Oh, yeah. Very cool. Now, the principle here is action and reaction. For every action, there's an equal and opposite reaction. You can't hit without being hit. As a matter of fact, it's an interaction, my hand and the board. Forces are all interactions between two things, the earth and the moon, the hand and the board, a foot and a football. It's always an interaction. But you know what? Teaching is also an interaction between a teacher and a student, between a student and a student. You can't just convey information or give instruction in that fashion. You've got to interact to be able to really teach. I love teaching. I want to make it fun. I want to put a lot of energy into it. I want to make it real, and I want to engage the students in discussion and thinking and interaction. That's what it's all about. Now, at the Pathfinders Institute, you're going to have a lot of skills. You're going to go over here. You're going to learn how to reach your students. You're going to have an amazing time this week.
Hi, David.
Hello.
I told the teachers that you would be with us live, and that after they saw all of your demonstrations, they would have undoubtedly some questions. I do invite those teachers who are with us as attendees to please use the Q&A feature on your screen. Begin typing your questions as I engage David in a discussion, and I'll turn to your remarks momentarily. So David, energy, energy, energy was repeated throughout your presentation, and I think a lot of our teachers now are going to be working at a distance to really convey that enthusiasm to their students. You too went through a virtual period of time this spring. How were you successful in still conveying all of that energy through the screen?
Well, I brought all my toys home with me. You've seen some of them today that I used. And I love being able to, they said, Dr. Wright, you actually kept the same enthusiasm and energy at home that you had in the classroom. And that was important because it's hard enough to be doing a virtual lesson to have like this, you know, teaching them like this and just telling them things. I learned a long time ago, energy is really an important aspect of how I teach. I've got to teach energetically. I've got to have enthusiasm. I've got to engage the students. I use the polling feature on Zoom. I asked them lots of questions and got their response. I wanted to get them as engaged as I possibly could. And it was a real learning curve. So you all had the same experience this spring.
How did you get the students, from you to the students, you can control that energy. How did you get them I think some of our teachers are going to need to get their students interacting with one another. Do you have any tips for how they could be effective with that?
Yeah, we struggled with that because a lot of them were having tough time at home, dealing with their kids being home from school and with our labs, and so we didn't know quite how to do that. So we're trying to work with things called breakout rooms we have in the Zoom and get the people into groups of 3 or 4 so they can actually interact with each other as opposed to just having an interaction in the classroom. The breakout room has to be a really big deal for labs in particular, for interaction with the students.
So most of the teachers that we have with us, the 400 or so, are leaning into computer science. Out of the 400, we had about 173 who are teaching other subjects, some of them maybe even physics, but they're trying to infuse technology and computer science into the classroom. Have you experimented a little bit with that yourself? Do you have any advice for those teachers?
Let me tell you an example. I've taught math before. And whenever I taught math, I tried to find great physical examples of what was happening. So we'd be talking about how you'd solve a physics problem using math as opposed to just putting equations up on the board. So I'd say make it as practical as you possibly can. The demo manual I put together is about physics, but physics relates to everything. It's the king of the sciences, as we say. So I would take some of the examples in the book. It'd be on your resource rack here before too much longer. There's like 82 different demos you can do, and you can relate those to the mathematics of that. You're modeling it on a computer. It's just a way to keep the thing relevant, you know, touch the real world and not just talk about the theory of things. I would have died in my physics class if I just talked about theory. I had some math teachers that thought that math was a pure science in itself. It wasn't supposed to relate to the real world. That's nonsense. You got to relate to what's happening in these kids' lives. We go on roller coasters in my physics class. There's some great equations, quadratic equations to try to explain the forces you feel on roller coasters and so forth. They go to a playground. There's all kinds of math that's tied into this. You can do some nice computer modeling. It's amazing stuff.
Well, I think for the teachers who are watching you, David, and some of the comments that are coming in, they all want to know where to get the document that you referenced. And it's a little bit of the trick of hosting a virtual conference of the time things are really happening versus your remarks. So I want to let everybody know that we did produce a list of all the exciting creative activities you do with students. We've put that on the resource hub. So for those of you who are looking for some ways to apply maybe the creativity that David showed into your own classrooms, I think you'll find that there. I think that energy and that vulnerability is why we are excited to introduce you, David, to all of our teachers. In many instances for them, this is so new. When we've met teachers before, when we're in real life, they say, I'm scared. I've never done computer science before. I know my kids need to know it, and I'm going to lean in. And I think what you're showing, you really put yourself out there, and it seems like the students respond. Is that a fair statement?
It is. They really get into it. I mean, I had so many students say, I was so afraid to be in this class. I didn't want to be here. I was scared to death. And you made it real by tying it into the real world. And I learned a long time ago when I took physics in high school, for example. This is the textbook. It was a later edition of this. You know what's the name of the author of this textbook? Charles E. Dull. You cannot do that to physics students. And that was my inspiration. I had a elementary school teacher who made things fun. I learned that class can be fun and the students will respond. He'd make it real for them. He also cared about us. You can't just teach people to be teachers. They have to care. That's a really critical element. If you care about them, you get them involved in real world kinds of things like we're talking about. You show them the way, you model it, and you take it step by step. You assume nothing. Assume they don't know what they're doing, and you'll just take them step at a time. I thought when I took my high school physics class, the guy was a great guy. He was a competent teacher, but the words passion and energy and enthusiasm never entered into the classroom. Sometimes the equivalent of reading the New York Times, for example. But I thought there ought to be a way to explain things exciting and interesting and fascinating as physics. Make it live. And that's been my goal, to make it live. So they could leave the class thinking, hey, this stuff is pretty cool. The world operates under laws. I understand some of those laws now. Oh, what a deal.
Well, I think that we have some questions wanting to know where you get your activities, but I think the fresh perspective you have that the classroom needs to constantly change and be evolving very much speaks to the teachers who are pushing into the computer science space. We can't do things the way we once did. And I think even now, after the past 3 months, these teachers are feeling it even more. So we really wanted to all of the teachers who are watching and seeing David, you probably got more of a physics lesson than you were expecting, but we really loved David's energy and thought a lot of that same approach is so transferable to those of you who felt you're always trying to up your game and thereby your students benefit. So David, to close, can you give our 424 teachers their onward march inspiration for the week?
Well, the key element is professional development. That list I put together took me 40 years to put together. So I wanted to share it with some of you, save you some time. You talk to colleagues, you go to Infosys conferences, you read journal articles, you talk to your colleagues, you do all kinds of stuff, one step at a time, introduce things. And so this week, you pay attention. How is this going to apply in my class? How can I make my class more exciting, more relevant to the real world? You'll find all kinds of things you can do to get your sparks going. You'll never be quite the same after this week. I hope, in a good way, never be quite the same. So, but just be patient. It took me a long time. I started off in a very traditional role in the teacher, did the same thing I'd seen done. I saw 1 or 2 demonstrations when I was in college. You can do it. And be yourself. I would say, learn how to be yourself. And you are you. You've got certain talents and energies and insights that nobody else has. People will be excited to have you as a teacher because you're doing your best to improve each day, to make it relevant, fun, exciting, and tie it all together. So they'll have a great a time in class as you will teaching. I think you're in a great place to be right now. It's awesome.
Oh, thanks, David. I couldn't say it better. You're now an ambassador for our institute. I just want to say thank you for the time you put into preparing for the teachers and for being here tonight with me. We'll put information about how you can reach David on the Resource Hub. And again, you'll find the whole document he has referenced there if you'd like to download and print. And for the moment, David, we'll say good night for now. And thanks again for being with us.
If you don't get some of this stuff, just ask questions. I'll be able to fill in the gaps for you.
Great.
Bye, everybody.
So much, okay.
It's great being here with you.